Joel Gawangya, a lecturer from the Faculty of Information Technology, as our guest speaker this afternoon, and allowed me to provide a brief overview of Dr. Joel's works, experience, and academic contributions. Okay, Dr. Joel holds the bachelor's degree of computer applications from CMS College of Science and Commerce, Coimbatore, right? Coimbatore, India, and a Masters of Computer Applications from Bharatiya University in India, and a PhD in Computer Science from Karpagam University in India. And before joining AIU, Dr. Joel was a lecturer at Lowry Adventist Memorial College in Bangalore, India. And some of his notable achievements include 7 published research papers and 2 review papers, and then reviewer for an international journal, session chair for an international journal, members of editorial boards for the National Conference on Trends and Technologies in Multidisciplinary Research, and then chief guest lecturers at Karpagam University for researchers, master's students, and undergrad students. And then there are many more, and I don't think that I can cover all of them to give more time for his speech. So please join me in welcoming Dr. Joel Gawangya, who will now present his research topic, genetic algorithm model, automated activity schedules at AIU. So Dr. Joel, the floor is yours, and give hands to him, please. Before we start, let's bow heads, we'll pray. The Father in heaven, we thank you once again this afternoon that we will have the opportunity to hear from our expert, Dr. Joel, to share with us his topic. We pray that you will enlighten us with knowledge and understanding. And thank you for the rain that you showered to this land to cool down the weather, Father. And this afternoon, this 1 hour will be productive and meaningful to learn from Dr. Joel. Thank you, Father, for hearing our prayer this afternoon, for we ask you in Jesus' name. Amen.
Thank you so much, Dr. Nakon, and dear faculties and the staff. Thank you for having me and for being here on behalf of our research department. I'm so excited that I'm the one who is starting this research series. It's my first time, and I pledge that from today onwards, I will try my best to be in these series. I think I haven't attended. That's my fail. I really admit. I'm very sorry, Dr. Nakon. I did not attend, and I don't know what's going on. So, but I kept receiving the messages, I have to admit. Probably since you gave me this task, and I see we are here few, I pledge that I will attend next time forever. I will try my best to attend. All right. So first of all, to start with this question was ringing in my mind, why me? Why Dr. Nakon, he chose me to be the first for this semester to come and present. And again, this question was answered by this topic, or the title which we have here, a genetic algorithm model for automated activity scheduling at AIU. I'd like to give a credit to Mr. Sebastian, the head, now the one who is leading like the research for this academic in our faculty. I'd like to give him a credit for bringing up the topic, the things which we can work on as a faculty. And I also like to thank the colleagues as well who are working with me and with Mr. Sebastian as well to make this research become success. So I would like to start with this one now. Okay, now let me start with this. Okay, just how to play. This is a play. Okay, can you please play this one? What does this tells us? Yeah, please. Yes, sir. Okay. I think you have seen this many. Can you please expand it?
A snake's eyes aren't very good, but they can detect movement. So if the hatchling keeps its nerve, it may just avoid detection.
You can go back, yeah. All right, so what comes in your mind when you see this? Dr. Maxine was looking down, oh my goodness, this iguana is dying. So many snakes, right? But how this is related to what I'm saying? In biology, you have something called the nature selection. The nature selection is a process by which the organism adapt to survive or to live in environment, right? They adapt to live. So this iguana, imagine living in that area where millions of snakes are there, and is so many things to learn from this, right? It escaped. It escaped. Next one. Let's look to the nature now, which we have here. Look into these cactus from the desert, camels in the desert. They all need to survive, and they have to live because they were designed in that way. When I was trying to study all these things to connect with my presentation for today, it really amazed me the way these cactus are created by God. They absorb the water. They have the outer layer, which has to prevent sun or anything which can take water from it. Means it just protects the water within it so it can survive in any heat, especially in a desert. So all these are the nature selection. All this nature selection, they take us to my topic, genetic algorithm. To my surprise again, I came to know that we are all having the same gene. The same gene, yeah. 99.9 something is the same. The only, 0.000 we are different. So interesting. But these differences are the one which made us, they're the one which make us unique, which make us survive. So, to this topic, genetic algorithm, we'll be able to introduce to you something called optimization problem, or how can we solve problem. Now, I know this is elementary question, but consider yourself and myself going for a trip. And this trip, it is all about, there is a rule for the trip. To board in airplane, you need to take the luggage, which is less than or equal to 3 kilograms. Among all these objects, which one can you pick? We have here different objects. We have the water bottle, we have this massaging bottle, we have a laptop, which is weighing 2.4 kilograms. Remember, we need only to take 3 kilograms. And these 3 kilograms should be in our backpack. Okay? And we have the shoe, we have the phone and the headset. We need to pack for our, trip. Now, if we do the first calculation, which one will you pick? Remember, should it be below or equal to 3 kilograms? We go along with, we take this, that's my choice, right? I may take this one, maybe phone is okay with me, always, and the shoes, of course, and I take this one, maybe I take the water bottle, maybe these 3 items I can take them. But it depends. For you may say, hey, maybe I may not be able to finish my work. I have to use my time. You may take a laptop, you choose a laptop. What does it mean? Means we are trying to solve this problem in different ways based on the choices and based on what could be the best for you or for me. So this problem solving or trying to solve this problem is similar to what genetic algorithm will help us. Keep it in mind. This is something which can calculate. Now imagine if you have 1,000 objects to pick. Choosing is becoming very difficult. Similar to our genetic algorithm. Maybe when we come into the problem statement itself, we will come to understand it. So when we say genetic algorithm, it's a powerful method for optimization problem. Again, as we look here in our daily life, we optimize. We optimize in one way or another. For example, you try to reduce stress, right? Means you are minimizing stress. Your optimization, I want to look something which can reduce my stress. You are optimizing. You are just trying to find the solution for the problem among many solutions. Either you go recreation or you stick on time. When the bell rings, I have to do something. If it's a break, I have to break. If it's for going home, I have to do that. There are many ways we can do that. Second, you may optimize for maximization. Number one, you can optimize for minimization, means you try to reduce, and you can try to optimize for increasing. For example, I minimize my time in the office, I maximize my time with the family. So, genetic algorithm, which we are, if I say we understand the faculty of IT, we have introduced and we want researching on it, is to help AIU optimize its work. To help Asia Pacific International University optimize this problem. We have so many activities here in AIU And one of the area which is critical and which is time consuming, which needs diligence and somebody who is keen, it's in academic offices, especially in a registrar's office. Registrar's office, they need to schedule class in such a way there will be no conflict. They need to schedule the classes in such a way there will be no conflict in the courses, there will be no conflict for the classroom or for the room allotment. So according to you, do you think how many days, how many hours it may take them? It takes them. Did you think about? A lot, right? Daniel, is it a day?
I was just thinking about that yesterday.
Mm-hmm. Good. So it's only one person, Mrs. Vararisa. If Mrs. Vararisa, by the wish of Satan, if she's sick, then we are behind. So she has to be awake, she has to be fine all the time. Otherwise, it will be behind. It can be done, but it will take long time, right? Optimization will be so much, will be time consuming. So, Mrs. Vararisa, she's the one who is dealing with this one. We, myself, Mr. Sebastian, we have done the first work to interview the registrar's office. We get information that they may take not lesser than 3 days just to be on this class schedule. And yet, as a human error, there may be some mistakes there, right? Which is not solved. Now, can you imagine the amount of time spent doing this? Let's say, God is willing, if we still have a time here in this world, and our university has 10,000 students, how will it be? And can you imagine, these things is done manually. There's no system to help. Just sit down, come on a board, just, okay, Dr. Gakwai will teach this one. Okay, what about Dr. Nakon? This. Try to think how to solve this. As we see the optimization, it may fail. Sometimes you may make a mistake, you can't be able to revert it, to bring it back. So the research focus which we have, genetic algorithm, it is mimicking this, it's imitating the genetic from the biology, from the science, but in IT scenario. So we use the same way just to adapt and to make the system be able to, as the system keep growing, then the solution we keep producing the solutions. You understand? We keep having different solutions as the population keeps growing, and then the solution keeps also updating, and we keep have many ways to solve it. All right? So that's why we proposed this this technique by using genetic algorithm. This is the aim. We want to improve the efficiency of activity scheduling at AIU, and also we want to demonstrate the benefits of using genetic algorithm based on a system for activity scheduling at AIU. So we need to reduce the time, and we need also to make sure that the errors which you can make can be avoided. I remember before calculators, it was easy to use, calculation from the mind, right? But the moment you introduce to the calculator, you slow down in calculating. But calculator is doing a good job. Same way here, they may be able to be accurate to do it, but how far and how much time and how long it will be. So we need to update in such a way the system can help us to schedule our activities. So these are the literature review or things which have been done, the same technique, genetic algorithm, which has been used. For example, here Hadi and the co-authors, they have used this GA-based for allocating the time and the slot. So it has been also used and the feasibility of the courses, how the course can be able to be achieved at the time. It has been suggested. And in 2016 as well, the suggestion was being made to try the part of it which is called the crossover and the mutation operator. Probably when I calm down, I'll try to explain how this will help us to solve the problem which we have here in AIU, as well as the GA or genetic algorithm was also introduced to be one of the algorithm which can help us to achieve the time consuming or the time spent in scheduling classes. This was the research question, which is, can a genetic algorithm based system be more effective than heuristic based method? So heuristic, it's a manual or automated. And moreover, this heuristic, you need to be experienced. So when you are new, you can't be able to adapt to the heuristic. So you need to be to have experience so that you can use it. So we have to consider the factors such as efficiency, constraint satisfaction, and user satisfaction. So we have three hypotheses. Number one, we have genetic algorithm-based activities. Scheduling system would generate schedule with a fewer conflict compared to other heuristic and the meta-heuristic method. So we try to avoid, number one, to avoid the conflict with the classes. That's the first hypothesis. The second hypothesis to the same question, a GA-based system would produce activity scheduled that are more efficient in terms of resource allocation. For example, allocating the looms and time and equipment which can be used than using the manual or experienced person who rely on his own experience. The third hypothesis, the users or university itself or the staff who will be using the system will find that the GA-based system is more easy and more flexible than the current system which is used today. So these are the three hypotheses which we center our research and try to improve it. Now, the methodology which we're trying to use is a GA, as I mentioned, a genetic algorithm. And I would like to explain how it will work in this sequence diagram, okay? In this sequence diagram. So we have the user, as we mentioned, the staff, or the person who is in charge of using the system. He or she is the one who will initiate the task. Initiate the task in a sense, let's say, starting, for example, to generate the classes. So the genetic algorithm will support in creating something called initial population. Population is collection of individual solutions. Among optimization, we have different solutions. So population, we have individual solutions, for optimization problem. So we have different solutions. So we'll have initial one, which will be initiated by the genetic algorithm. And then there will be evaluation fitness function or a way to check the score, which one is better among these solutions in scheduling. For example, we want to schedule the class. we put the classes and the teachers, and then it will show us what could be, let's say, what could be the arrangement which can avoid the conflict. So we'll have different solutions there. And then evaluation fitness will look the best one. For example, if it is 90%, there is no, let's say 80%, there is no conflict, then there will be, again, come back here to the genetic algorithm. And then genetic algorithm will run this again, just to check among the selected one, let's say top 5, solution is better than the 10 which is generated. And then again, we perform the selection. The selection method is to choose the best also. We want to choose the best among those which have been selected. Yes, please. From a computer, not from a human. This is a function from all this is within the computer, the algorithm developed. So, but the selection, all these terminologies as is in the biology will be the same. And the crossover, here we have something called the chromosomes. So the chromosomes, you know, these are the best solution. Just take it like that way. I avoid to use that one. The chromosomes are the best selected solutions. Here, right? That's how they call. And then crossover, we need to mix 2 solutions, and then we can see what could be the best. That's called the crossover. Now, once that is done, then the algorithm will also to perform another function which we call mutate. So this mutate is just, I want to bring a random, you know, let's say a random selection in this one, a slight random to see how the changes will be, how effect will be. So we'll come here, and then we again evaluate and see. Remember, in this line here, or here, we want to find the score. We'll have to list down the score, right? And then we see which is the highest, and then that highest will be the one to be picked as our last output, which can be the last solution for the course evaluation. So this is the entire basis, entire idea of the things which we are about to do in our research. Now to conclude, this will be the best, and this will be the way, easy way to adapt, and easy way to continue to grow the university activities. I mean, the university to grow in the terms of student, in the terms of activity, in the terms of things to be scheduled. So this is multi-purpose, but first will be implemented in a class schedule, in a registrar's office. Thank you very much. That's all. Algorithm is developed. We are now developing. Yes. Which one? We will develop from the scratch. Yes. Yes, please.
Thank you very much, Dr. Joel. And now it's questions time, right? Q&A session. Okay, Dr. Kamunan.
Thank you, Ka. This is very interesting, Ka. You use all the terms from the biology genetic book. The word user means the input, right? You put all the input data inside. Like, is it possible that we can just give the computer that here's the student year 1, and here's the classes that they're gonna take. Student number 2, probably year 4, here's the classes they're gonna take, and all of the 1,200 students, here's the data. Can they just
that's the one.
Go in the kitchen, and then there becomes like class schedule for us?
Yes, that's what we do here. That's the purpose.
You finish? You are working on the tools.
Yes.
Okay. Okay.
Yeah, we started by purchasing the research server. The purpose of using that is because this requires a high-intensive calculation process. So we will run several, how to say it, evolutions or cycles of evolution massively and in parallel. That's the purpose. And along with that, this is not the only algorithm, but we have also other heuristics to run, plus the manual process. So,
Dr. Maxwell.
This is mind-blowing. It's excellent. But at the end of this, whichever system we choose, will anybody be able to say, okay, here's the data, do it? Or will you have to have someone who's skilled to run it?
I think the skill, no, in any, just to introduce, to say this one, in any software deployment, there are something called, training. So the people, they can be trained how to use it.
All right.
Right, yes.
Sure.
In your robot, can you add something? For example, like can you add bias? For example, like year 4 student, the senior student, they are less flexibility in their class schedule. Like they must have at a certain time or at a certain day, whereas the first year student may be more flexible, like you can scatter them here and there. Can you ask the bias in some extent? Yeah. Can, right? So you're gonna make something like automatically for us. We just do the input and then it will just click and then it will come up to plan 1, plan 2, plan 3, and the selection come by human law. Okay. Yeah. Because when I asked Mrs. Valalisa to teach me how to do the schedule, she said it takes year to learn. It takes a long time.
The program, the algorithm is a program, right? Or is it?
Yeah.
Do you have like a format that you can use, that you can find, that you can kind of copy, or you have to actually write the program or yourself?
Yeah, right. It's just a type and yeah.
So you have to. It's like a type, then you can kind of
Yes.
work with.
There are two concepts maybe to clarify. One is the algorithm and the other one is the program or the implementation. They are two different things. The algorithm is imaginary. It exists in theory. So when you want to bring it down to the earth, you have to type it. Now the algorithm can be used for any purpose. It's just a matter of adaptation or customization, let's say, for the specific problem. And this particular problem is very complex. Since we handle a variety of different variables, like the availability of students, teachers, room, laboratories, equipment, and so on and so forth. The intention of this research is to customize this algorithm for the reality of our university. There are many that have been done, but for realities of other universities or other institutions, even not necessarily academic environment, but also, let's say, hospitals or any institution. So this is basically an algorithm that tackles the problem of permutation. Which is the best arrangement in the schedule table to come up with an optimal solution, yes, or timetable.
Are there any more questions from the floor? I just want to ask also. In that case, it means that there is an registrar's office or the person to key in your data to look for the class clash, and then you can use this to analyze it. Is that what you mean? We need to key in data, right? You don't have a computer to generate data itself, right? Are there people to need to key in data and to check out the class scheduling and all the activities running here at AIU, and then you will see the picture how they are, how you come up with the output, the schedule, the best one, the best solution. Is that, I don't know if I understand it correctly. I mean, you need people to tell you the detail, what class going on and here and there, even they plan the class or the courses. No?
We need to, as we mentioned, the first one is user. Means we take the entire student, let's say the entire class. Let's say if it's a first year student for this course which we want to schedule, and then we can feed it in the system, and the system will give us the output, generated output where student can be.
You need data from users, right?
Yes, of course,
okay.
of course. Return just a feedback, just give the means the process when, 1 minute, I forgot to mention here, look, these are the code that activate the duration, how long this process will be. So here when it returns means from this duration from the schedule here, it gives you the output here, the output from this duration.
Can you generate these tools without having the crossover or the mutation? Or it has to be there? I wonder why mutation is important in this generation.
The mutation, it's important just to, let's say, to validate whether there can be a conflict in a case there is, let's say, there is long input, right? So that's where we can use just to test to make it sure that it is perfect, is working well. Yeah, in the case of random selection.
And this mutation are created by the researchers, or is it random, or how does it work?
Genetic algorithms in the same way as other type of search algorithms in artificial intelligence, they deal with a universe of possibilities. So every single point in the universe represents a solution. But in advance, the algorithm doesn't know that. So the way how to explore this is basically random. Now, the mutation, as Dr. Akwaya pointed out, is intended to avoid conflicts, or in other words, to broaden the area, or the hyper area, because this is a hyperspace, to select solutions that are not being considered before. So just imagine this room. Every particle of air is one solution. So how to cover, or how to how to find the optimal. And that's the purpose of mutation, to increase the variety, or the space, the area for searching. If you look one by one, since this consider, let's say, 50 or 100 variables, for a computer could take millenniums, if one by one. There is no way to solve this problem in other way. This is called NP-hard problem in computer science. Now, genetic algorithms tackle that problem, randomizing the search. It doesn't ensure a perfect solution, but very close to the optimal, and depends on how you implement selection, how you implement crossover, how you implement the fitness function, and yeah, basically those, and the structure itself of the chromosome.
Yes, the best fitness.
When is this project to be complete? My
Yeah.
questions. Because AIU, I think, will be very happy for the registrar's office and maybe the SAs also, right, for planning the activities, so we will not see the class clash and so many conflicts.
Yes,
Right.
it will.
Yes,
It will. It has
it
to.
will happen soon,
Yes.
right?
Sure. Soon.
Yes, they turn in their project. Yes. It's
Already.
approved, right?
It's approved already.
Yes,
Yes.
approved แล้ว อาจารย์Elvin. I think Dr. Damrong was there, approved the budget.
All right. So.
Are there any more questions from the floor? No more? Okay, if we don't have any more questions, then we have, just a small gift of appreciation from our research office. May I invite Dr. Kamonnan, our VP AA, to present the gift certificate to Dr. Joel. And then we will end with the closing remarks and pray by Ajahn Panindra, the faculty dean from IT.
Yeah, I would like to thank the research office for giving this opportunity, and thanks to Mr. Sebastian, Dr. Gakwaya, Mr. Sebastian for leading the project, and we'll all be part of it. And at least from all the questions, just to answer how I understand it, is I want a baby with a long nose, curly hair, and the eyes like Chinese. So what do? Get